Hello, grade 10. So today I'm going to start with a little bit of review of lesson 4.3, and then I'll also go through lesson 4.4 with you. So you should have a handout in front of you that's 4 pages long. The first 2 pages are a review of 4.3, and then the last 2 is the new lesson for today. So at the top of the first page, it says review of vertex form. Number 1. Give the vertex form of the quadratic relation and then explain the effects that the various letters have on the look of the graph. So vertex form is y equals a bracket x minus h squared plus k. And now we'll talk about what each letter does. So a represents the direction that the parabola opens. So if a is negative, it will reflect. So reflects if negative. And A affects the graph by stretching it. That's if A is greater than 1, or compressing it if A is between 0 and 1, so A is a fraction, and that's stretch or compress by a factor of A, so that means that it's multiplied by A. H shifts the graph left or right h units. Shifts left or right h units. And you need to remember that it's the opposite sign of the equation. So if the equation is y equals 3x minus 2 squared plus 7, this looks like a negative 2 for h, but because the original equation is x minus h, the value of h here is 2. So this would shift the graph right 2 units. Okay, so you need to remember for h inside the bracket, it's the opposite sign of what it appears. And then k shifts the graph up or down k units. All right, number 2, make a sketch of the following equation. Y equals negative 5 bracket x minus 6 squared minus 4. All right, so we're going to start with a table of values of the parent function, the parent equation. So the original equation before any of the transformations were done to this equation was y equals x squared. So we know that because if we took away all these transformations, we would just be left with an x squared. So we're going to start with a table of values for y equals x squared. So there's some room there to the right where you could write this on your paper. So the columns are x and y, and we're just going to pick a good range of x values. You choose these are the independent values. Negative 3, negative 2, negative 1, 0, 1, 2, 3. Just a good range of negative and positive. When we plug these numbers, these x values, into our parent equation, y equals x squared, then we get y equals negative 3 squared, which is 9, y equals negative 2 squared, which is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So now we're going to go to our graph, and we're going to draw these points on the graph. All right, so I'm going to start with these points. My scale, I'm going to go down to negative 24. So let's go down by 3s. So this would be negative 3, negative 6, negative 9, negative 12, negative 15, negative 18, negative 21, negative 24, and then up the same. And then on the x-axis, I want to go up to at least 10 and negative 10, so I'll just go up by 1s. Don't forget to label your X and Y axis. All right, so once you have your scale done, then you're going to plot these points from your table of values on your graph. So -3, 9. -2, 4. -1, 1. 0, 0. 1, 1. 2, 4. And 3, 9. And then connect those with a nice smooth curve. All right. Then the next thing we're going to do is the A value. So the A value is -5. So that will change all of our Y values by multiplying each one times -5. So if I do 9 times -5, that's -45. 4 times -5 is -20. 1 times -5 is -5. 0 times -5 is 0. 1 times -5 is -5. 4 times -5 is -20. 9 times -5 is -45. So now my X column is staying the same, and my Y column is changing. So my new points are -3, -45, -2, -20, -1, -5, and so on. So now I'm going to plot those points on my graph as my second transformation. So I'm not going to do the -3 and the +3 because those go down to -45, and that's not on my graph. So I'll just start with the -2. So -2, -20. -1, -5. 0, 0. 1, -5. And 2, -20. And then I'll connect those with a nice smooth curve. Okay, so that's my second step. So that's where I'm at right now. Then I'm going to do the H value of 6. H equals 6. Remember, it looks like -6, but because the original equation is X minus H, this is the H value that was inserted was +6. So everything's going to shift right 6 units. So each point, I'm not going to use a table of values for this one. I'm just going to take each point on my blue one, and I'm going to move it to the right 6. So starting with 0, 0, would now go 1, 2, 3, 4, 5, 6. That would now land right there. Take this -1, -5 and move over 6. 1, 2, 3, 4, 5, 6. Take this +1 and move it over 6. 1, 2, 3, 4, 5, 6. Take this -20 and move it over 6. And this -20. 1, 2, 3, 4, 5, 6. Okay, and then I'll connect those larger dots with a smooth curve. So now the shape has stayed the same. It's just moved over 6 units to the right. And then my last transformation is going to be this -4, which is my K value, which will shift my graph down because it's negative 4 units. So I'll take the last points from the dark blue here and move them down 4. Now remember, my scale is going down by 3s, so I just need to make sure I'm going down 4 units. So this one will land right about here, down 4, down 4, 20 to 24 to 24. And I'll connect those with a smooth curve. And green is my final graph. And the equation of that I will label is y equals -5 x minus 6 squared minus 4. And that's the final graph here. All right, number 3 says, put the equation from number 2 into standard or expanded form. So we'll start with the original y equals negative 5, x minus 6 squared minus 4. And in order to put this into standard form, I just need to expand. So I'm going to start with this bracket and write it beside each other. So y equals negative 5, x minus 6 times x minus 6 minus 4 equals negative 5. Now I'll expand this out by multiplying each term in the first bracket times each term in the second bracket. So then I have x squared minus 6x plus 36 minus 4. I'll simplify by combining like terms inside the bracket. So x squared minus 12x plus 36 minus 4. And now I'll get this negative 5 into the bracket by multiplying it by each term inside the bracket. So I'll have negative 5x squared plus 60x minus 180, and then that negative 4 on the end. And then I can go combine the negative 180 and the negative 4. Negative 5x squared plus 60x minus 184. And that's now in standard form. Okay, the next page says why the sequence or order of transformation matters. So it says, although some equations will produce the same parabola regardless of the order of transformation, some will not. Therefore, it's important to apply the transformations in the correct order according to BEDMAS. For example, given the function of y equals x squared, a vertical stretch of 3 followed by a vertical shift of 2 will not produce the same graph as a vertical shift of 2 followed by a vertical stretch of 3. So if we switch them around, the graph will look different. Draw both scenarios for the equation y equals 3x squared plus 2. So the first scenario, a vertical stretch of 3 followed by a vertical shift of 2. So we're going to start with the parent function, which is y equals x squared. And I'll do the same thing I did last time and go from negative 3 up to positive 3. So you can just write this below the graph there. There's a space to write this. So we'll start by drawing on both of our graphs this table of values. Actually, I'll do 2 here. Okay, so this is going to be scenario 1, and this will be scenario 2. Alright, so I will draw, I'll go up to 6 on the x-axis and up to 12 on the x-axis, so up by 1s on both of them. You should be able to get up to 12 on yours. Okay, so negative 3, 9, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, and 3, 9. And the same one over here. So that's the parent function. Now if I go back, and next I do a vertical stretch of 3. So that means I'm going to multiply each number in the y column by 3. So I get 27, 12, 3, 0, 3. Oops, this should be 4 and 9. 12 and 27. Now I'm going to plot these numbers. I won't be able to get up to 27, but I'll do the ones in between. So 12, negative 2, 12 would be way up here. Negative 1, 3, 0, 0, 1, 3, and 2, 12. So that just stretches it right up. Okay, so that's the first transformation, and then followed by a vertical shift of 2. So now we're going to go up 2 for each one of these. So I'm just going to take each of my points and move them up 2. This one should go here, not there. And that will make my graph look more like this. So blue here is the final one. All right, now I'm going to do the same thing for scenario 2. Just use the same table of values. But this time I'm going to first do the vertical shift of 2 and then the stretch of 3. So I'm first going to add 2 to each of these. I'm just going to do it on my graph here. I'll do it in red. So up 2, up 2, up 2, up 2, and up 2. So I did the vertical shift first. So that leaves me with 11, 6, 3, 2, 3, 6, 11. Now, the next step is to multiply them by 3. So I did the addition first, then the multiplication. So that leaves me with 33, 18, 9, 6, 9, 18, 33. So I can't do 33. I can do, no, I can't even do 18. Negative 1 and 9. 0 and 6. 1 and 9. Connect those, and that will go straight up. And that is now my final one. So you can see that the two final blue ones are very different. The left one here is correct because it does the multiplying before the adding. See how, sorry, I erased it, but the multiplying was done first and then the adding, and that's correct according to BEDMAS. So you always need to do the A value before the K value. Okay, moving on to the 4.4 handout. So it says, relating standard form to vertex form using symmetry. Recall, quadratic equations can be written in 3 different forms where each form of the equation provides different information about the parabola. The factored form of a quadratic equation is y equals a, x minus s, x minus t. The standard form of a quadratic equation is y equals ax squared plus bx plus c. And the vertex form of a quadratic equation is y equals a x minus h bracket squared plus k. It's possible to convert from one form of the equation to another by using different tools. To go from factored to standard, you need to expand. To go from standard to factored, you need to factor. To go from factored to vertex, you would find the midpoint of the zeros, which is the axis of symmetry, and then find the y coordinate of the vertex by putting the x value, the axis, back into the equation. And lastly, to go from standard to vertex, you can completely factor, or you can partially factor, which we're going to learn today, or you can complete the square, which we're going to learn next time. All right, key ideas. Regardless of which form a parabola's equation is written in, the a value remains the same. For example, write this equation in vertex form. Y equals 2 x minus 1 times x plus 4. So to go from vertex to go from factored to vertex, we need to find the midpoint of the zeros and then find the y coordinate by plugging it back into the equation. So we can find the zeros by setting each section equal to 0. X minus 1 equals 0, x plus 4 equals 0. That means x equals 1 and x equals negative 4. So those are my zeros. Now we're going to find the axis of symmetry, which is the midpoint of the zeros, halfway between. So 1 plus negative 4 divided by 2 is negative 3 divided by 2 equals negative 1.5. Now we have the first part of the vertex, negative 1.5 comma blank, and we need to find that second part. So in order to do that, we're going to take this negative 1.5, plug it back into this equation in both spots for x, and then that y that we get out will go here. So y equals 2 times negative 1.5 minus 1, negative 1.5 plus 4 equals negative 1.5 minus 1 is negative 2.5, and negative 1.5 plus 4 is positive 2.5. Multiply those two together, or all three of those numbers together, and we get negative 12.5. So my vertex is negative 1.5, comma, negative 12.5. Now we need to put this into vertex form. So the a value stays the same. So we'll have y equals 2, bracket, vertex form is x minus h, this is h, so it would be x minus negative 1.5, which is x plus 1.5 squared minus 12.5, and that is now in vertex form. Sometimes it isn't possible to completely factor a parabolic equation. In this case, partial factoring produces two symmetrical points which can be used to find the vertex of a parabola. So, for example, y equals x squared minus 4x minus 11. So for this one, if we wanted to factor, we would find two numbers that multiply to negative 11 and add to negative 4. Well, that's not possible, so we're going to partially factor. So we're just going to look at the first two terms. We're going to ignore the negative 11 for now. So we're going to look at those terms and say, what can we factor out from those two terms? In this case, we can only take out an x. So we're going to have y equals x, bracket, x minus 4, bracket, and then leave that negative 11 on the end. Now we're just going to look at still the first section, and we're going to split it into two sections and set each of those equal to 0. So x equals 0 and x minus 4 equals 0. And then solve for x, just like we do when we find the zeros. So x equals 0 and x equals 4. Now, these two we can treat them like the zeros, because on our graph, there's going to be, they might not be on the x-axis, but they're going to be across from each other with the axis of symmetry down the middle. So they're still going to be the same distance away from the axis of symmetry. Now, what are these points? They are 0, negative 11, and 4, negative 11. So 0, negative 11, that little number hanging on the end, and 4, negative 11. That's what these 2 points here would be. Now, we can treat them like the zeros and use the axis of symmetry to find the rest of the vertex. So we're going to look at the x-coordinates and say 0 plus 4 divided by 2. This is going to be our axis of symmetry. So 4 divided by 2 is 2. So my vertex is going to be 2 comma something. I'm going to take this 2, plug it back into my original equation for x, and I'll be able to find the rest of the vertex. So y equals 2 squared minus 4 times 2 minus 11 equals 4 minus 8 minus 11. 4 minus 8 is negative 4, minus 11 is negative 15. So the vertex is going to be 2 comma negative 15. Now I can put this into vertex form because I know the vertex. The a value is going to be the same a value as the original equation, which is 1 because it's not written there. So y equals a value of 1, I don't need to write that. X minus 2 is the first part of my vertex, squared, minus 15. Notice how I put in a negative here, even though this is a positive number, because vertex form in the bracket is always x minus h. So whatever h is, I just plug that in there and leave this as a negative. Okay, the second example in that box says y equals negative x squared minus 6x minus 13. So again, this can't be factored, so I'm going to partially factor by looking at the first two terms. So I can take a negative x out of this. So negative x plus 6, because I'm dividing by a negative, and then that negative 13 on the end. I'll split this into two sections and look at each one separately. So negative x equals 0, and x plus 6 equals 0. Divide by negative 1, x still equals 0. Subtract 6 from both sides, x equals negative 6. So my 2 points that are equally apart from each other on this parabola are 0, negative 13, and negative 6, negative 13. Now I'm going to find the axis of symmetry, which is halfway between those x-coordinates. 0 plus negative 6 divided by 2 is negative 3. So the vertex is negative 3 comma something. Take that negative 3, plug it back into the original equation for x. Y equals negative 3 squared minus 6 times negative 3 minus 13. Negative 3 squared is 9, plus 18 minus 13. Negative 9 plus 18 is positive 9, minus 13 is negative 4. So the vertex is negative 3, negative 4. So to put this into vertex form, I need to take the same a value, which is negative 1, or just negative, it's the same. X minus 3 is my h value, so that would be x minus negative 3, which would be x plus 3 squared minus 4. Okay, I only have a 30-minute time available on this video, so I'm going to continue this video in a second video called part 2. So go there now.